Let's solve problem 352. Determine the force in each of the three cables needed to lift the tractor, which has a mass of 8 megagrams. So here's our free body diagram, and this tractor has 8 megagrams down. So clearly the chain is going to be 8 megagrams up. And we want to change that to weight because that's mass. So we'll multiply by 9.81 and get 78.5 kilonewtons up. So we're going to have a force going from A to B, from A to C, and A to D. So I'm going to call those FB, and this one is FC, and this one FD. So we need to write each of these in vector form so we can add all of our forces and set them equal to 0. So to do that, we're going to do, for each one of these three, we're going to do a position vector, a magnitude of the position vector, the unit vector, and then the force vector. So the position vector of B is, from A to B, is 2 in the X, negative 1.25 in the J, and negative 3 in the K. So we'll write that here. 2 in the I, minus 1.25 in the J, minus 3 in the K. Now, to find the magnitude, we're going to square each one and add them up and take the square root. I'm going to ignore signs because we're squaring them so they go to 0 anyway. And so we get 3.82 those meters. So we're dividing each of these by this. So 2 divided by 3.82 is 0.52 in the I, and then minus 0.33 in the J, and then minus 0.79 in the K. And so turning that into force vector, all we do is then put the magnitude FB on each one. Okay, so if PC goes from A to C, is a similar coordinates position, except for J, in this case, is positive. So we're going to do 2I plus 1.25J minus 3K. Same magnitude there. And the unit vector is the same number except for change the sign. And then we'll throw in the FC. Now for PD, it goes 1, negative 1 in the X, and down 3. So it's negative I minus 3K. So 1 squared is 1, 3 squared is 9, 1 plus 9 is 10, square root of 10 is 3.16. And so the unit vector there is negative 0.32 in the I, minus 0.95 in the K. And the force vector, D, is negative 0.32 FD in the I, minus 0.95 FD in the K. So now we'll sum the forces. And let's see here. Let's put this right here. So sum of the forces in the X are going to be 0.52 FB, 0.52 FC, minus 0.32 FD. and sum the forces, that equals 0. Let's sum the forces in the y, and we get negative 33 FB and plus 33 FC, and that equals 0. And sum the forces in the z, and we get equals 0, and we get 78.5 up minus 0.79 FB minus 0.79 FC and minus 0.95 FD. So now we have 3 equations and 3 unknowns, and it could be solved easily using a graphing calculator. By hand, I would start it by using the middle equation. Right there, we can see that if we move FB to the side, FC is equal to FB. And then if we take the top equation, we can write this equation out, and for FC, I'm going to add in FB. So 0.52 FB plus 0.52 FB minus 0.32 FD equals 0. So combining this, we get FD is equal to 3.25 FB. So we can do C and B in terms of C, so but FB, so put those into there, and we get 78.5 equals 0.79 FB, and move these 3 to the other side so it became positive, minus 0.79 FB plus 0.95 3.25 FB. Solving for that, we get FB equals 16.8 kilonewtons, which is the same thing as FC, is 16.8 kilonewtons, and then putting that into there, FD is 3.25 times 16.8, and we get 55 kilonewtons.